Okay, hello everyone. Okay, today we're going to discuss polynomial functions. So this is a relatively new chapter. Okay, so by definition, let's discuss what polynomial functions are. So polynomial function is a function of the form f of x equals a sub n, x raised to the n plus a sub n minus 1, x raised to the n minus 1, and so on and so forth until you get to the last two terms, which is a sub 1 x plus a sub 0. Okay, now you know all these a sub n's. Okay, they're all constants. Okay, but in this case, a sub n should not be equal to 0. Okay, so these are all numbers. Okay, so coefficients are real numbers. Okay, so a sub n actually is what you call the leading coefficient of the polynomial function. Okay, and then whatever the highest power is what you call the degree of n. Okay, and the last term, a sub 0, which is in here, is what you call the constant term. Okay, now a polynomial function is in standard form if the terms are written in descending order of exponents, which means the power of x should be decreasing all the way down to the number. Okay, so basically these are the types of polynomials. We already discussed some of them, which is the linear and quadratic functions. So another introduction would be the cubic. The highest power is 3. And then the quartic function, a polynomial function, the highest power is 4. So these are the examples. Okay, so let's have an example. Now decide whether each function is a polynomial function. So if it's a polynomial function, we write it in standard form and identify the degree, the type, and the leading coefficient. Okay, so look at the first example. So you have now here f of x equals negative 2x to the third plus 5x plus 8. Okay, this is an example of a polynomial function, right? Okay, it's already in standard form because as you can see that the powers of x are decreasing as we go from term to term. So x to the third, and then it becomes x until we get to the constant term. Notice that the highest power is 3, which means the degree is 3, which is a cubic function. And then the leading coefficient, the number next to the highest degree is negative 2. Okay, let's have another example. Okay, so in this case, you get now g of x equals negative 0.8x to the third plus square root of 2x to the fourth minus 12. Okay, now notice this is also an example of a polynomial function. However, the powers are not arranged in decreasing order, so I have to put it in standard form. So we know that it's a polynomial function. So all you got to do to move it into standard form is to move square root of 2x to the fourth up to the front. Okay, which means I get now this one. Notice that the highest power is 4, which means the degree is 4. And the number, or the real number next to the highest power, is square root of 2, which is your leading coefficient. Okay? So, how to evaluate polynomial functions? So, evaluating polynomial function is just simply substituting the x value that you want. Okay? Just like, say, for example, if you want to evaluate the polynomial function 2x to the fourth minus 8x cubed plus 5x minus 7, when x equal to 3, all you got to do is just simply get the value at 3. Okay? So notice f of 3. I'm basically substituting x as 3. So 3 to the fourth is 81. 81 times 2 is 162. And this is 27 times 8, which is about 72. Oh, okay. And then you have now 5 times 3, which is 15, and then minus 7. I get the answer to be 98. Okay? So, now y-intercept is the value of y. So this is another one. You're going to learn this later on. When x equal to 0. So if you're looking for f of 0, you're just simply determining the y-intercept. Now, if I want to get the y-intercept in this function, all I got to do is just substitute 0 here. So it's going to be 0, 0, and 0 here. What's going to be left is just negative 7. So f of 0 equals negative 7, which means the coordinate 0, negative 7, which is the y-intercept, is in the graph of f of x. Okay, you're going to learn this is an important thing when we do the graphs. Okay, So what we're going to do today is to determine the function from their graphs and properties. But in order for us to do that, let's first determine some definitions, okay? So first, we need to know what the roots are. Roots are what you call the x-intercept, which means in the graph, when you look at the graph, it's where the graph crosses the x-axis, okay? So if the graph crosses the x-axis, that's the roots, okay? Next is what you call, this is an important one, what you call turning points. So this is the point in the graph where the graph changes from increasing or to decreasing or decreasing to increasing. So which means from going up and then going down, the point that are going up and then going down, the point that where it changes the direction is that you call the turning point. Okay? So a polynomial of n degree will have n minus 1 turning points. And an n turning point will have a square factor if it's an x-intercept as well. So this means that if your polynomial function is of x to the third, you'll have 2 turning points because the highest power is 3, so it's n minus 1. That's the reason why when it's quadratic, you only have 1 turning point, which is your vertex, right? Because the highest power of a quadratic function is 2, which means it will have only 1 turning point, okay? And the last one is you already know what the x-intercept is. So we're going to use all of these 3 in determining the equation. Okay, let's have an example. Okay, so example number 1, this is the graph. Okay, the question is, what's the function that gives this graph? Okay, now let us look at the graph and determine important features. Okay, what do we notice? We notice first that the graph intersects the x-axis at 1. As you can see, I'm pointing it right here, and 2, right? Negative 2. 1 and negative 2. However, there are 2 turning points. Negative 2 is a turning point right there. See that? Because it's going down and then it goes up. And there's another turning point there at 4, right? So it's going up and then after that it goes down as well. So notice the x-intercept is at x equals to 1. That's why. Which means x minus 1 is a factor. That's one of the factors. Also, there's a turning point and an x-intercept at x equals negative 2, right? So here, which means if it's a turning point and it's an x-intercept, it's a square factor. So it's going to be x plus 2 quantity squared is a factor, okay? So if I combine that two, because you already have now the following properties, the full function for this graph is this. We don't know what a is, okay? It's x minus 1 times x plus 2 quantity squared. But we need to know what a is, okay? Now, to know what a is, we know that the y-intercept is what? 4, right? Which means 0, 4 is a part of the function, okay? Y-intercept is 4, so which means that's the y value when x is 0. So which means f of x equals 4 when x equals what? 0. So I'm just going to be substituting that. F of x equals 4 and then substitute x as 0. So 0 minus 1 is negative 1. 0 minus 2 is negative 2. Squared, it's 4. So 4 times negative 1 is negative 4. Okay? So that's going to be, multiply that. Okay? So a, 0 minus 1 is negative 1. This is negative 2 squared. It's positive 4. That gives you 4 equals negative 4a. And then if I solve for a equals negative 1, which shows me that the full function is actually equal to, okay, negative 1, okay, times x minus 1 times x plus 2 squared. So just substituting a. Okay? Have any questions so far? Okay? Now let's have another example. Now look at the graph. Okay. How many turning points does it have? So I have now 1, and then 2, and then 3. Which means if it has 3 turning points, the polynomial is of the form x to the 4th, right? But let's see what do we have here, okay? So we have an x-intercept and a turning points at 1 and 5, right? Which is a squared factor. So first we have at x equals to 1, as you can see from here, which means x minus 1 is a squared factor. Also, It's a x-intercept and a turning point at 5, right? Which means x minus 5 is a square factor. Okay? Now, which means my full function now is actually this. F of x equals a times x minus 1 squared times x minus 5 quantity squared. Okay. Now look at the graph. The graph has a y-intercept at 30. So, which means f of x equals 30 when x equals what? 0. Okay. So if I'm going to have that, simplify that further, I get 30 equals 1 times a times 1 times 25, which is actually 25a equals 30. So if I'm solved for a, I get a equals 30 over 25 or 6 over 5, which implies that my answer now is 6 over 5, because I found my a, times x minus 1 squared times x minus 5 squared. Okay? Now, sometimes, aside from the graph, they simply present it to you as a table or even a description. Okay, let's have an example. Now, the function f of x is a quartic function, and the zeros are of f of x are -6, -5, -2, and -1, and +1. Assume that the leading coefficient of f of x is 1. Write the equation of the quartic polynomial in standard form. Now, when we speak of a quartic function, it means the highest power is 4, right? So which means if these 4 numbers are the roots, which means if -6 is the root, which means x plus 6 is a factor. If -5, x plus 5 is a factor, and x plus 2 is a factor, and x minus 1 is a factor. So if I multiply that one, it's going to be something like x to the 4th, right? But we're going to be assuming that the leading coefficient of f of x is 1, which means a equals what? 1. So which means my function is actually this one, okay? Now, it's easier if you multiply all of them so that you get the actually, because you want the answer in standard form, okay? So, which means I have to multiply all of them. So if I multiply the first two, I get x squared plus 11x plus 30. Well, the next two is x squared plus x minus 2. So what I'm going to do is to multiply this two, okay, using a table. So still I have the problem there. Notice. So 11x, x squared plus 11x plus 30 multiplied by this. So the inner boxes are basically the products. And then I'm going to arrange. So x squared is x to the 4th. This one, and so on. So it's basically the product of, let's say, 11x squared is a product of x and 11x. Then I'm going to collect terms. So x to the 4th is alone. Then x cubed is 11 and 1, that gives you 12. Okay. And then for x squared, you have 30 and 11, which is 41. 41 minus 2 is 39. And then 30x and 22 is 8. And then minus 60. So that's why you get now this. Okay. Now, in some cases, you're given a table. Okay? Now, what's the equation based from the table? Okay. Now look, which means the x-intercepts are from here, -2, -1, and 3, which means we have a cubic function, which means we have x-intercepts, implying that we have x plus 2, x plus 1, and x minus 3 as a factors, and then we don't know a. But the y-intercept is at what? -6. So just substitute -6 for f of x when x equals 0. There you go. And then when you simplify that, you get a equal to 1, which implies if we want to multiply that, okay, my full function would now be a equals 1. Just multiply all these 3. So first I multiply this 2. That's going to be x squared plus 3x plus 2 multiplied with x minus 3. Then I'm going to do the distributive property and then combining terms. So notice that 3x squared cancels with the 3x squared right there. I get x cubed minus 7x minus 6. Okay, so this is how you determine the equation based from the table. Okay, Do you have any more questions? Okay.